Assalamu alaikum. In this video we will discuss the data representation. And why we discussing the data representation? Because we have to move towards the memories, and when discussing the memories, so data is an important factor. So we have two types of signals in which the data is transmitted. The first type is called analog signals, and analog signals are continuous in nature, and it says infinite states. And when discussing a digital signal, and that is a language used for computers, and we have just two states when working with a digital signal. You have a on state and you have a off state available with respect to the digital signals. You have just two states with the digital signal, and when comparing the digital with the analog signal, we have infinite states available, and most of the computers are working on digital level, but humans are working on an analog level. If I am speaking, so I am producing the analog signal, but different computers communicating with each other with the help of digital signals. And the bit is the smallest unit to measure the binary number system. If you have a 0 or 1, so it means you have a 1 bit here and a 1 bit here, and when you are combining the 8 bits together, so that becomes a 1 byte, and that is also called a word size in a computer. So bytes and bits are the measuring unit of our digital signals. So digital signal, it's also representing with the one of analogy of electrical system. So if you have a presence of signal, that is representing with the 1, and if you have an absence of signal, that is represented with the 0 or the off state, 1 or the on state, 0 or the off state. So they have the same idea when working with the digital signals. So if you combine the 8 bits together, so look at this thing, the number 4 is representing with the combination of 8 bits together, so that becomes a 1 byte, and that is one of our measuring unit in computer system. So the presence of charge is 1 and the absence of charge is 0. And when we move towards the data representation, the ASCII is one of a standard we have to discuss. So it's American Standard Code for Information Interchange, and that is a most widely usable code nowadays, and all the computers nowadays are working on a ASCII level. There's a little bit difference between the ASCII and a binary number system. Look at this thing. If you have to represent the 0 in terms of ASCII, so you have this type of a coding, and that is a totally different coding when comparing with the binary number system. In a binary number system, you have a complete set of zeros available here when representing a 0, and when working with the ASCII, so you have a 1 is appearing here at a location of 4th, 5th bit. This is a 8-bit number. ASCII is a one of a number which is representing with the help of 8 bits. So at a location of 1, 2, 3, 4, 5, 6, at a location of 5, 6, you have a presence of signal. So that is a way of representing the 0 in terms of ASCII. But if you want to represent the 0 in terms of a binary number system, you have a complete set of zeros available here. So that is one of a difference between the ASCII and a binary number system. And similarly, 1 is representing with the presence of signal here, but you have a same pattern repeating up till number 9. So look at this thing, number 9, you have a double 1 is appearing here, and the rest of the factors are same. Look at this thing, 9 is representing with the 1, 0, 0, 1. So this is a 1, and this one is a 8, so 8 plus 1, that becomes a 9. So but that is a binary 9. When you also if you want to represent it's with the help of a ASCII number system, so you have a 1 appearing at here. And similarly in ASCII we also deal with the alphabet, so A is representing with the these bits of streams of bits, and you have a 1 is appearing at a location of a 7th bit, so 1 is repeating in this factor, and it's starting from a 1. This one is 2, 3, 4, 5, 6, 7, and you have a 1 is appearing at a location of 7th. So that pattern is repeating up till Z. So look at this thing. So that is a way of representing the ASCII number system, and from onward I works with the ASCII number system. I not say like that the computers are not working on the binary number system, but the computers are working on the ASCII number system, because the main factor of designing the computer is a communication, to reduce the communication gap. So when we want to communicate the different computers together, so we have to work on the same standards, and that is one of our standards developed by the Americans. So one computer is working on ASCII, the other is working on ASCII, and they can share the information with each other. But if one computer is working on ASCII, the second is working on some other language system, so it's very difficult to communicate with each other. So that is the reason everything when discussing the communication, everything is working on the ASCII number system. And again you have some special character also associated with this thing. You have one continuous 1 is appearing at a location of it's a 6 bit. Yes, it's a 6 bit. So you have a 1 is appearing, and then you have a special code patterns here. So here's the one of our example how anything, when you enter anything from your keyboard, is how it's converting into visible patterns. So for example, when you press letters from your keyboard, T is here, and this diagram, when I press the T from my keyboard, so it's creating a one of a scan code. So my keyboard is creating a one of a scan code, and that scan code moves to fetch by the CU. So your processor is here, the CU control unit fetch the scan code and decode the code into a binary number system. So the scan code is converting into a binary number system, and then they performing the calculation on the binary or the ASCII number system, and then it is visible to us in front of our screen. So it's a conversion. Again, when you enter anything from your keyboard, it's creating a scan code which is fetched by the CU. First, the scan code moves towards the memory, and from the memory the CU fetch the information and decode the results into ASCII number system, and then send the result back towards the output unit. So that is one of a machine cycle I am discussing here. So fetch, decode, execute, and store. So that is the same example here. So now moving towards the memories. So memories again is one of electronic component, and that's used to store the information, instruction, and the data needed for the instruction, and the result of that your data. So if you want to add something, for example 2 plus 5, so that 2 and 5 is the data for us, and then the plus factor is the instruction. So you have a data, you have an instruction, and overall result is 2 plus 5 is equals to 7. So 7 is your resultant. So store the instruction, store the instruction in terms of a data, store the operation on that data, and store the result of your data. So it's storing the three factors: the data, the operation on that data, and the resultant, overall resultant. So it stored the three things, and the other three things the memory is used to store as the operating system and the system software. The operating system, for example, we have a Windows operating system, we have a Linux operating system. So when you turn on the system, the first thing load into your system is the operating system. So the memories is also used to load the operating system, and some of our system software. For example, you open the Chrome browser, so Chrome is one of our system software, so it's used it's also load into the memory. And the other application software you are working with, for example, if I am using the Camtasia software to recording the video, so that is one of our application program, so it's again loading into a memory. And the third thing is the data, which I discussed here, data in terms of instruction, operation of that instruction, and the result. So the memory is used to store all the things together, so that is a very important thing when discussing the memory. Store the data, store the it's load the operating system, it's load the application program or the softwares, and so on. So when discussing the memory, each location in the memory is associated with the one of one of the address. So the memory is addressed with the one of addressing system. So and when the working with the memory, so we have a different size available in the market. So you have a KB, kilobyte sizes available, we have a megabyte available, giga, and a terabytes available. Look at this thing, bytes. So again, it's not a gigabit. Bit is a measuring unit of a speed when we are working with the internet speed. So we say I have we have a 2.2 megabit per second speed, and when we are working with the memories, so we works with the bytes, so that is a bigger unit. So that is the reason we working with the memories. When working with the memories, we use the bytes, and when working with the internet speed, we works with the bits. So here is one of a table available. The kilobyte is approximately equals to 1024 bytes, and approximately it store 1.5 page. And similarly, megabytes is equals to this number, and approximately we can store 500 pages when working with the megabytes. We have two basic types of memories available. The one is a volatile memory, and its losses contents when you turn off the power supply. It's one of example of the volatile storage is RAM. So that is one of example of a volatile memory. And we have a non-volatile memory is also available. It means when you turn off the power, it's not losses the contents. So that is your flash drive. Yeah, that is your hard disk. So we have a different example. We have a flash memory, you have a ROM available, that is a permanent storage, and the CMOS is one of a technology used when working with a non-volatile memory. CMOS is a complementary metal oxide semiconductor technology, so that is one of a technology used to build the non-volatile memories. So when we discuss the machine cycle, so we see the two different types of a memory. The in between type of a memory is a volatile, and you have a storage available at the bottom, so that is a non-volatile memory. So we have two different types of memories also used in the machine cycle, and here's the two memories available. So we have a RAM, that is a random access memory, and that is not a permanent storage. When you turn off the power, everything in your RAM is wiped up. So that is the second type of a memory that store the data permanently. Here's one of example how program instructions transfer in and out of RAM. Here's the example. This is your hard disk, that is a non-volatile storage available, and when you turn on the system, the first thing operating load into your RAM, that is a volatile storage here. So the everything is loading from a non-volatile towards the into a volatile storage area. So operating system load first into your RAM, and it's visible at your output. And for example, you open a web browser software, so again it's load from your hard disk towards the RAM, and it's appear at the output. And you open some paint program, so it's again loading into your RAM and appear at the output. And when you switch off any program, for example, if you want to remove the web browser from your desktop, so you just remove it from a RAM, so it goes back towards your hard disk storage. So it's only removed from your RAM, but it's not removed from your hard disk, because that is your permanent storage. It's remove the instruction from the RAM, and these instruction goes back into your hard disk. So that is one of our example how the software and the data or the program is transferred from the hard disk, and how it's transferred from back towards the hard disk from your RAM. So when discussing the RAM, so we have three basic categories. The first one is a dynamic RAM. It's also treated as the DRAM, and that is a chip need to re-energize continuously, otherwise it loses the content. Mean you need 100% electricity to turn on these type of RAMs, so they are not energy efficient, of course. And we have a different variation when discussing the DRAM. The first one is SDRAM, that is a synchronous DRAM. S stands for synchronous. Why it's called a synchronous? Because it synchronizes the clock speed with the clock speed of your system. So RAM is working on a different in its own clock speed. The system is working its own clock speed. When you match the clock speed of the two electronics components, so you get the better efficiency of overall system. So that is the reason they come up with a synchronous DRAM, and they are much faster than DRAM, because they are not synchronized with the clock speed of your system. The second variation in a dynamic RAM is a double data rate SDRAM. So of course its transfer rate is double as compared to the DRAM, and it's also synchronized with respect to the clock speed. And you have a DDR2, that is a second generation DDR. Of course it's faster than DDR1, and then you have a DDR3 available. It's a third generation DDR, and nowadays the most of the systems are working DDR3 level. And we have another RAM available in the market that is used the one of a pipelining technique is associated with the processor, which is associated with the processor. So it's the RD RAM, that is a RAM bus DRAM. So it's used the pipelining techniques, and it's much faster than the dynamic or the synchronous DRAM, and it's used for your servers environment. So it's a little bit costlier than these generation of the RAMs, but this produce a more better result as compared to the DRAM. The other two types of the RAM is a static RAM. Why it's called a static? Because we don't need constant source of energy to turn these RAMs on, but when comparing with the DRAM, we need a constant source of energy when we work towards a static RAM. So we don't need to be continuously give the power to this device to run, and it's much faster and more reliable when comparing with the DRAM, and it's also energy efficient RAM, because we don't need 100% electricity. It's only work when the data is present into your RAM, otherwise it's not utilizing the energy. So that is the reason it's energy efficient RAM. And the third type is a magnetoresistive RAM, also called MRAM. It's a newer technology. Instead of electrical signals, it's used the magnetic signals to store the charge. The static and the dynamic RAMs are used the electrical signals to store the data, but the magnetoresistive RAM use the magnetism or the magnetic charge instead of electrical charge to store the data. And the manufacturers claim it store the efficiency of this RAM is much higher as compared to the static and dynamic RAM, and it's use the less power, and fast is also give us a faster access time. So that is one of advanced form of a RAM available in the markets. So memory chips are usually resides on the memory module. So you have one memory modules available here, and memory chips are integrated over that memory module, and this memory module is inserted into the slots available in your motherboard. So that is a way of inserting the RAM chips into your systems. So here's one of our example what type of a memory we needed. So if you have just a home user or a little bit business type of a user, you just need some word application software. We just working with some Excel software, so we go for the 2 or less than 2 GB RAM. That is enough for us. But when we need a little bit more things, for example, we need some videos to run into your system, so you have to increase your capacity of the RAM. So it's works with the 2 to 8 GB. And when we need the 3D gaming, or we want a 3D designing softwares, or a graphic software which use the intensive softwares, so we go for a 8 GB and above RAM. So that is one of example how you choose the RAM. So it's totally depending on the type of a software we are running into in your system. So it's only depending the type of a software. If I'm working with the 3D software, so of course I go for a 8 GB or 8 GB above RAM. But if I'm not working with the these type of 3D simulation or a CAD software, so it's workable. 2 to 8 GB is going to be enough when working with the memories. So the other types of the memory is the caches, and that is one of memory used inside your processor. In the earlier presentation, in the earlier lectures, I discussed another type of memory which is used to run the operation inside the processor chip. So we have three different types of caches available when working with the system. So L1 cache and L2 cache is a part of your processor. When processor fetch the data from the RAM, so there must be some storage area inside the processor chip, so that hold the data, and that is a storage area. That is just a storage area to just hold the data for the operation, further operation. So you have a L1 cache available, you have a L2 cache available. L1 cache is a fastest cache, and most of the frequently usable data is present at L1 cache. And we have a L2 cache. It's again faster, but not faster as compared with the L1, so it's a little bit slower than L1 cache. And the L3 cache is a separate chip between the processor and the RAM, so it's integrated into your motherboard. So you have a look at this thing, you have a 1, 2, 3 and 4 volatile storage available. So you have a L1, L2, L3 and a RAM available for CU to access the data. For example, CU is assessing the data, so CU first checks the L1 cache. If the data is not available in L1 cache, then it moves towards the L2 cache, and if the data is not available in L2, it goes towards the L3, and then after that it goes towards the RAM. So of course RAM is not providing us a much better speed as compared to the L1, L2 and L3 cache. And you can also check the cache of your system. So if I go into the search programs and file option of a Windows, so I go into the task manager option. Look at this thing, you have a task manager available, and where I have to go, yes, okay, look at this thing. I go to the performance of the CPU, and here is the size of my L1 cache, L2 cache and L3 cache available. Look at this thing. L1 cache is smaller in size, but it's the fastest. It provides us the fastest response. L2 cache is a little bit higher than the L1, but it's a little bit slower response. Give us a slower response as compared to the L1. And then you have a L3. It's a little bit more, but it's a compromising if you with the L1 and L2. So other factors are also available. Look at this thing, the cores. It's also give us the information of the cores of my system. I have 2 physical cores, and I have 4 logical cores. It's mean I have a quad core processor in processor used in my system. You can also check the cores of your system with the help of this command diag. Okay, diag. Yes. So if you open this thing, so look at this thing, a lot of information is available. You have a memory size available. I have a 8 GB RAM available for the system, and look at this thing. The processor is working with the 4 cores. So when you go into the properties of your system, so here's there is no information of a core available. We just have a Intel Core i5 generation 3 EU ultra low power CPU working at this speed, and nothing else. The core information is not present in the properties. It's available in this type of DirectX diagnostic tools, or it's available in task manager. So I have a 4 logical cores available, working with the maximum speed of 2.3 gigahertz approximately. You have other information also available. Look at this thing, the display card is the one of prefer thing which connect with my motherboard. So there's also information of my display card available. I have a two sound cards available connecting with my this system, so the information of the sound card is also available, and that is our input information. I use the mouse, keyboard, and HP wireless button driver. So these are the some of our input software. So this is one of a command used to see the properties of your system. So and the second is the task manager. You go into task manager, you see the performance of the CPU. The utilization factor is here. That means my CPU is working 56%, and when the utilization factor is 50 approximately 50%, that means the working cores are 2. The remaining 2 core is not using at that time, because it's a U coming at the end, so it's utilizing low power. Just running some of our recording software and just running the PPT presentation. So that is the reason the utilization factor is only 50%. The remaining cores are not active at that time. I just working with the 2 cores at that time. So that is our utilization process. And these are the threads we discuss in the processor attributes, and maximum speed is 2.3 gigahertz here. And here's the information of my memories. Okay, you have 2 slots. This means I use the 2 slots, 4 GB RAM in each slot, and that is the other things here. So moving back towards the memories,